Here, finite element method can be observed finding approximate solutions for partial differential equation. Here you see the dolphin fish is available. Surrounding of dolphin there are n number of triangular elements available. We separate the parts into n number of triangular elements. We can study one singular element that are available with n number of elements. We can modify or we can analyze the single element. From that single element solution, we can study all the elements that are available with the same rectangular boundary. So, from this, we can get the approximate solution with the aid of partial differential equation. And then, what is partial differential equation? Yes, a partial differential equation is a mathematical equation that involves two or more independent variables. An unknown function dependent on those variables. Here I told two words which are independent variables and dependent variables. I can explain what is meant by dependent, what is meant by independent with the aid of force. Basic formula: force is equal to mass into acceleration. Likewise, we studied in our school days also. So that here what is dependent variable and what are independent variables in FE is equal to MA formula. F is a dependent variable and M into A are the independent variables. So the dependent variables are depending the independent variables values. Okay, if I change the mass of the particle or acceleration of the particle, the force value maybe differs. Okay, which is the thing that are available with the partial differential equations, dependent and independent variables, and also partial derivatives of the unknown function with respect to the independent variables plays vital in partial differential equation. With the following example, we can understand. Yes, u is equal to x square plus y square. According to my lecture, u is the dependent variable and x and y are the independent variables, and xy dependent variables are decides the u value. So now you may understand what is meant by dependent and what is meant by independent variables that are available with the equation. And how can I differentiate this equation? How can we utilize the partial differential concepts with this equation? Let's see. Here I differentiate this equation with respect to x, so that I put ux is equal to dou u by dou x. U is the primary equation or parent equation. I differentiate this equation with the x, so that here I write as like dou u by dou x. If I differentiate the equation means here the independent variables are x square plus y square available. The x square, x is the derivative function, so that 2x I can write 2x because x power n is equal to n into x power n minus 1. The differential formula available here. The n is equal to 2, so that 2 into x power 2 minus 1. So 2x available, and then again I can further do the differentiation for the same parent equation. So the previous equation, not a parent equation, previous equation. So dou square u divided by dou x square, in dou u by dou x there is 2x available, so that I can differentiate the x with the x means I can get 1, so that 2 into 1 is equal to 2. So that dou square u by dou x square is equal to 2, which is the fundamental mathematics which are studied from our school days. After that, here I place some word, which is word is partial derivative. What is the meaning for partial derivative? Yes, you can see. Partial derivative means function. If I denominate any one function a comma b means function f of a comma b, which depends on two variables which are a and b, where here a and b are the independent variables. Then that the function f partially depends on a and b. Here I want to calculate the derivative of f. What can I do then? That derivative is known as the partial derivative. So if I want to perform the derivative function of f means which is known as partial derivative. So if we differentiate the function f with respect to independent variables that are a and then b means first I consider the a as a means b as a constant, and if we differentiate with respect to b means then take a as a constant, which is the concept that are available with the partial derivative. And then here you see f of a comma b is equal to 2a square plus 3ab plus 6a plus 7b. Likewise, the equation is available. So, how can we differentiate? How can we differentiate this equation? Yes, we can. Here, differentiate with respect to a. What happens to f by dou a? The function can be differentiated with a, so that the 2, already I told you the formula n into a power n minus 1, so that 4a I got plus 3ab. From that a is neglected because the 3ab is differentiated to the rate of a, so that 3b plus 6a differentiated, so that 6 plus 7 and b are the constant, so that I can remove the b element from that. Okay, I mean 6a. Okay, so b is the 0, so that I removed that element from the equation. So further I can perform the differentiation with that derivative, so that dou square f by dou a square is equal to, I again perform the differentiation equation differentiation concept, so I can get 4 because 3b as the constant and the 6 are also constant, so that I remove 3b and the 6 from the equation, so I can get 4. What happens if I differentiate with the b? Yes, we can see differentiate with the b, dou f by dou b is equal to the a is the constant, so that I can remove the a coefficient and a element from that equation, so that 2a square is removed. After that plus 3ab available, in that a is the constant, so that I can remove the a, 3b available, plus 6a, a is the constant, so that I removed that element from the equation. After that 7b, b differentiate with the b means I can get 1, so that 7 into 1 is equal to 7, 3b plus 7. I again perform the differentiation with that equation, means dou square f by dou b square is equal to 0. Likewise, I may got the solution from the partial derivative concepts. And then